Welcome everyone in this video. So today I'm going to show you how to simulate turtlebot3 robot with ROS1. I'm using Ubuntu 20.04 for this simulation, and I'm using ROS Noetic for this version for this simulation. Earlier I was using Ubuntu 16.04, and with that I'm using ROS kinetic version. So as you know now, the ROS kinetic version as well as Ubuntu 16.04 is of its end of life, so that's why I switched to the Ubuntu 20.04. So yeah, I am actually it's not like a tutorial video, it's sort of demonstration video, demo video. I'm going to show you how to simulate turtlebot3 robot. I'm using this tutorial for the simulation. I'll put the link of this tutorial into the description box so that you can easily reach out there. Okay, so this is in this video I'm just basically perform two action or two thing, which is to launch the turtlebot3 robot inside Gazebo, and second we will control the robot using teleop. Teleop is nothing, just to use a keyboard to control the robot. So we'll do these two things. After this part we will cover another part, which is to create the map. When I perform these two basic steps, then we have to perform another two step. One is to create the map of the environment in which the robot is going to move, and after that we'll perform the navigation. It's like autonomous navigation, so it will automatically reach to the destination of its destination, avoiding dynamic as well as static obstacle. So this is basically the plan of this whole demonstration video. So yeah, let's start the simulation. So first we'll click on this Noetic tab so that we can follow the Noetic specific instructions. So what I'll do, I'll launch the terminal first, and I'll cd to the desktop workspace and ROS workspace. So this is my ROS1 workspace. In this workspace I'll basically put all the workspace that I'm using with the ROS1. So we have to first initially set up some initial things for the simulation. So those initial things are nothing but just to create the workspace, separate workspace for turtlebot3. So for that we'll write this command mkdir-p. I'll name it same turtlebot3 workspace. You are free to name anything you want. I'm using turtlebot3 name for this, and src. This command will basically create two directories. One is turtlebot3, and inside that directory and another directory named src is also created. I'll hit enter and I'll check. If I hit ls command, then you can see there is a directory created named turtlebot3 src. I'll go inside this directory, turtlebot3 workspace, and if I hit ls again, then you can see the directory src is created. Okay, now what I'll do, I'll stretch this a little bit. Okay, so if you follow the ROS1 installation step, then in those steps, there is a command which write sourcing of ROS1 instruction inside the .bashrc file. What that step will did is, whenever you launch the terminal, the ROS1 is automatically sourced inside your terminal. But I haven't performed that step while installing ROS1. Okay, so now whenever I launch a new terminal, the ROS1 is not going to source automatically, so I have to launch manually every time. Why I did this is because I want to install ROS1 and ROS2 as well, so I do not want to automatically source any of ROS, whether it is ROS1 or whether it is ROS2. So that's why I have not performed that step while installing ROS1 or ROS2. So what I did, I create a alias for both ROS1 as well as ROS2. So that I just type alias command and it will automatically launch ROS1 or ROS2. So for ROS1, the command, the alias command that I created is Noetic init. So the first step is to initialize ROS. So for that I am going to type this command, Noetic init. This command will source ROS1, and if I want to source ROS2, I will type proxy init. But this is ROS1 based simulation, so I'll type Noetic init command. So as you can see, ROS Noetic activated. So now my ROS1 is initialized in this terminal. Now the second step is to go to the src directory. Okay, so now we are ready with the basic setup. Now we're going to follow this tutorial. Okay, so here you can see they are doing cd to the Catkin workspace src. This Catkin workspace is nothing but it's a directory, and we have already created that directory with the name turtlebot3. Okay, or if you named it code as per your convenience, what name you want to choose for that. So we have performed this step, as you can see into the terminal. We are inside this turtlebot3 src, right? Which is fine. Now we are going to copy this command. This will clone the turtlebot3 simulation specific directory inside our src directory. I'll paste this command here and I'll hit enter. This will clone all the turtlebot3 specific packages inside our local src directory. Okay, so the next step is to cd to the root workspace and then hit catkin make command. So we'll do cd ... which will redirect us to the root workspace. So now we are in root workspace. So now we'll hit catkin make command here. This will compile all the packages that we are cloned earlier. This will take some time. Okay, so as you can see, all the packages built successfully. Now okay, so now the second step is to source this newly created workspace, or after building the workspace we have to source it as well. So for sourcing this workspace, the command is source, and if you hit ls here, you can see there is two directory created here. One is build and the other one is table. Initially we have only one directory, which is src, but after building the workspace there are two directory created, one is table and the other one is build. So inside build directory we have all the executables related to the turtlebot3 robot, and inside devel we have our setup.bash file which will source this workspace. So after building our workspace, now the second step is to source it. So for sourcing we'll hit type command source devel, hit tab which auto complete the remaining things, and we'll setup.bash, hit enter. So this will source the turtlebot3 workspace which we have built just a few minutes ago. Okay, so if you want to verify whether this setup file is exist or not, you can cd devel here and you can perform ls. So you can see this is the file this is the file we have sourced right just above, with the command source devel setup.bash. Okay, so we'll move on to the root workspace again. So now our workspace is sourced successfully, so we'll follow tutorial, but that is next. So we have performed catkin make command. Now we are good to go, good to launch with these commands or these files. So I'm going to skip this this command, this file, and this file as well. These two commands will do nothing but just launch. This command will launch this turtlebot3 inside a empty gazebo world, and the second command, which is turtlebot3 world, will launch this world and this robot which is located here. So if you want to perform these two commands, you are free to perform, you can perform, but I'm going to skip this command. And one more thing, if there is a command says export turtlebot3 model equals to burger, so this command will export the model of turtlebot3, which model we are going to use. So you can see we have used they have used burger, and in this launch they have used waffle. So there are basically three model of turtlebot3. One is burger, and the second one is waffle, and the third one is waffle pie. So in these three launches they have used different turtlebot3 version. So it's up to you which model you want to export. I'm going to launch this world, this house, and we will create the map of this house in later videos. So that's why I choose. We can choose this one also, but it's not necessary that you have to choose this environment. It's up to you. So we'll choose this one. So for that, first we have to copy this command which will export our model. You can see this the model is waffle pie in this command, so we'll use waffle pie. So I'll paste it here. My mouse is not working properly. Okay. Now the second step is to launch this launch file. Okay, so I'll copy this launch file and paste it here and hit enter. So this will take some time to launch, so wait for it. And if this command is not going to launch successfully in first try, so don't worry. What you can do, you can hit Ctrl C to close all the processes which is spawned by this command, and you can re-enter or retype this command or repaste this command and hit enter. It will launch successfully after that. Sometimes it will fail to launch initially. So as in my case, I have successfully launched this command. I'll zoom to the model. So this is our waffle pie model of turtlebot3, and as you can see, the environment and the model robot both are launched successfully. Now I'll minimize this and this as well. Okay, so now we have successfully launched our robot and our environment. So the next step is to control this robot. So for that we will use this launch command here to control our robot. So let me copy this command first. So this teleop key launch file we will launch in another terminal, okay, not in this terminal. So what I'll do, I'll create a new tab here, and as I told you earlier, after whenever I'm launching a new terminal, I haven't the ROS one is not going to initialize automatically, so I have to first initialize ROS one. So for that the command is noetic init. This will activate the ROS one. And the second thing we have to do is to source our workspace as well. So for that the command is source devil setup.bash. okay, so as I'm on the root workspace, so that's why I haven't give the complete path. If you are on any other location, so you have to provide the complete path. Okay, so yeah. Now now as you can see, we are on the other terminal, second terminal. So we have to export our model as well, which model we are using right now. So we have to copy this export command and we'll paste this command here and hit enter. So now we have initialized ROS, we have sourced our turtlebot3 workspace, and we have exported our model. So these things are completed. Now we are good to go with launch this command. So I'll copy this command again and I'll paste this command here. This will launch the teleop keyboard here. So after launching this command, I can control the robot using our keyboard. So I'll hit enter, and you can see, to move or to control the robot, we have these 5 keys. Like W is for the moving robot to forward, S is for stop, and X is for to move robot to backward, D is for to turn the robot towards its right side, and A is for left side. Okay, so the maximum, as you can see, the maximum speed waffle pie model is to 0.26 meter per second. This is the maximum speed of waffle pie robot. And you can see for the maximum speed burger can achieve is 0.22. This is the linear speed, and below down is the angular speed of both the model. Okay, so yeah, now what I'll do, I'll move this window towards bottom and shrink this window as well, so that I can show you gazebo and terminal together. So I'll maximize this gazebo and make it small here. Okay, so yeah, here is a robot, and to move this robot, first we have to click on to this terminal. So when I click on this terminal, okay, so you can see the cursor is blinking here. Now that means we are on this terminal. So to move forward this robot, we hit W. When we hit W, you can see the linear speed is 0.01, which is very slow. So if I again hit W, the speed is going to increase. So with this we can increase the speed of our robot. As you can see, it starts moving very quickly now. It will go up to 0.26, not beyond that. So I'll hit stop here. Okay, so now I want to turn this robot towards its left. So what I'll do, I'll hit A again and again so that the turning speed is increased, and I'll hit stop here. And now I want to move it forward, so again I'll hit W many times. Okay, so it start moving forward. Now I stop, start S to stop. You can see some lag while the robot is moving. It's because of my processor, or because the simulation will take a lot of computation, so that's why sometimes you can see this lag while performing the simulation. So not to worry about that. If you have a good processor, then it will perform better, or if you have the dedicated graphics card, then it's much better for that. So no issue in that. So now the robot is stopped. So I want to check whether it will move backward or not. So for that I am going to press X. I am pressing it 2-3 times. So yeah, you can see that it will start moving backward. So yeah, I'll hit enter. I'll hit S to stop the robot. Now I want to move it towards its right. So for that I hit D key for that. As you can see, it start turning towards its right side, and I'll hit S here, and I'll hit W again, move it forward. Okay, yeah, so in that way we can control our robot. So yeah, we have successfully launched our robot inside Gazebo environment, and we have launched our robot as well. So yeah, the first part is completed. Now in second part I'm going to show you how to create the map of this environment, map of this house, and after the map we will perform the navigation, autonomous navigation for this robot. So yeah, so that's all from my side in this video. If you have any doubt regarding anything which I'll show you in this video, you can comment me down below, and I'll try to resolve if you have any conflict or have any issue while performing these steps. I'm not going to cover the installation steps of ROS 1 or turtlebot3. Actually turtlebot3 steps is covered in this, but I have not covered the installation steps. So if you want to know how to install ROS 1, so you can follow ROS official website, and if you want a video on that, so ping me down or comment me below. I'll try to make a separate video on that as well. Okay, so thank you for listening, and thank you for watching this video.